Okay, we're going to do rationalizing denominators. And before we start, I want to kind of talk to you about why we even do this in the first place.
Okay.
And actually, let me do one of them and then tell you why. Maybe that'd be better. We're going to rationalize it, meaning we're going to turn a irrational number into a rational number.
Okay.
Irrational means that it can't, if like square root 2, if I put that on my calculator or I try to figure out what times what equals 2, there isn't a perfect number that multiplies by itself that equals 2. It's actually irrational. It goes on forever. It's like 1.414, which a whole bunch of decimals and keeps going on and on and on. And so we're going to actually do some kind of mathematical thing so that there will not be an irrational number on the denominator. It will turn it into a rational. So we will be rationalizing it. Okay. All right. So down here on the bottom, there is an irrational number on the bottom.
Right.
And we want to make that to be a rational. And now I'm going to tell you kind of why it started. And now that we've done it, it's kind of like we're just going to keep doing it. This is at least how it was explained to me. Back in the olden days, before they had calculators and they had slide rules, before they had calculators, and I don't even know before they had slide rules, and I'm not sure you even know what that is. They had to find out what the square roots were, square root of numbers, they'd have to memorize quite a few of them. But if they didn't know the square root, they didn't have a calculator to tell them, and so they had these books they'd go to, and they'd open them up, and there'd be tables, and tables and tables and tables of any kind of square root that you wanted, and so so you'd go look them up. And so instead of this book having to list 1 over the square root of 3 and 2 over the square root of 3, anything that had a denominator with the square root in it, you had to rationalize it before you could look it up. Okay? And since most of our mathematics is that now all the computations and ways we teach things are based on not having the square root in the denominator, we continue with this practice. Does that make sense? Okay? And so we don't leave that square root in the denominator. And so we rationalize it. So we do that by multiplying it by itself. If I multiply square root 3 times square root 3, it just becomes plain old 3. Does that make sense?
Right.
But the rules of fractions don't work there. We can't just go around multiplying things on the bottom without multiplying on the top. Otherwise, we would be changing the value of the fraction. We're not trying to change the value of the fraction. We're just trying to get it so that the denominator no longer has an irrational number. So we're going to now multiply this, and it's going to be 5 over the square root, 5 times the square root of 3 over 3. And now you can go to, if you didn't have a calculator, you could have gone to a book and looked up what the square root of 3 was, multiply it by 5, divide it by 3, and then you could get your value. Okay? We have just rationalized the denominator. This practice of rationalizing the denominator is going to be useful in other things, not just because we don't want to look at a book anymore and we have calculators to do it. But
so I have a question though. Like, why is it 9 right here?
Oh, good question. Because the square root of 3 times the square root of 3 is the square root of 9.
Okay.
9, which the square root of 9 is 3.
Okay.
Okay, does that make sense?
Yes.
Okay, and I just skipped that part.
Okay.
Does that make sense? Questions? Any others?
No.
Let's do the next one. I have a square root 2 on the bottom. I don't want an irrational number. We want a rational number. So I'm going to multiply it by itself.
So by 2.
And I also have to do the numerator, otherwise I'll change the value, and I don't want to do that. What's going to be in the denominator?
2.
Yes. And now, what's this going to be on the top, on the numerator?
A 4 square root 2 square root 3 or square root 3 square root 2.
Yeah, what is the square root of 3 times the square root of 2?
Oh, square root 6.
Good job. So it'll be 4 square root 6. Does that make sense?
Yes.
Okay, now, one thing we do need to check, and I should have made sure, actually this one won't matter, but this one, we multiplied some things to get the 6. We need to make sure that there wasn't any perfect squares in there that can be pulled back out. The factors of 6 are 3 and 2, and so there isn't any doubles to take out, so we're good. But you'll always want to check that there wouldn't be any doubles in there.
Okay.
Okay? If you had the square root of, if we had 4 and we had the square root of 6 here, and then we multiplied by the square root of 2 again, this doesn't have any doubles. This doesn't have any doubles, but when I multiplied together, there would have been, okay?
Okay.
Okay. All right. Now I have a radical in the denominator, but this time I have a letter. Just one second. This time I have two things in the denominator, but only one of them is irrational. So I don't need to multiply by the 2, just the square root of the 3x. Okay? And I have to do that on the top and the bottom. So I'm legal here with my... So I'm still going to have a 2. And the 3x and the 3x become... 3x, yeah, because they're both square root. We undo it, so we have a 3x there. Okay? And what do we have on the...
7 square root 3x.
And so this down here is going to become...
6x, right?
Yes. Now we're going to talk about something back here. All right. These 3's don't cancel. Do not. One's inside and one's out, okay? These 2 and the 6 don't reduce, but we should have reduced this 2 and this 4.
Oh.
Okay. So that 2 and 4 is going to reduce, and I'll have 2 square root 6. Okay. Does that make sense? Yes. We can't cancel or reduce from inside a square root to outside, but we can the other ones. Now this one, these x's cannot cancel because one's inside and one's not. Right. Can the 6 and the 7 reduce?
No.
No. We're done.
Okay.
Okay. Okay. Here we go. This time. So we're going to... you're going to have to factor that one and see what we can do to pull something out. Now this 18 is bigger. See, right back here we were doing 3. 3's prime. Nothing can multiply by to 3 except 3 and 1. But 18, we might be able to take some things out. 18 is 9 times 2, which is 3 times 3 times 2. Does that make sense? So I can take something out.
You can take out a 3.
3. So this will be 5 over 3 square root 2. These are the same thing. Okay, this just looks different, right?
Right.
Now, I don't have a... What is my my irrational number that we have to get off the bottom?
The 2.
The 2. So I have to just multiply by the square root of 2.
Okay, so then up top you'll have the 5 square root 2, and then a 3 underneath.
Yeah, so 3 with that 2 there, right?
And so that'll multiply to be 6.
Yeah, so we'll have 5 square root 2 over 6. So what you'll need to do is you'll just need to check whenever you have something that's not prime, that we can check that it has some factors to take out first and then. Now, if you would not have done this to begin with, you would have at the end check. So it wouldn't have hurt to wait till the end. It's going to be a bigger number, and it'll be more stuff you have to take out and then cancel. So it's actually better to do it at the beginning, but if you forget at the beginning, you can go all the way through and then take it all out at the end.
Okay.
All right. We're done. We've rationalized the denominator. That meant that we can't have a square root or irrational number, the radical, on the bottom. Okay. And we had to multiply by itself on the top and bottom, or the numerator and denominator, to make it work.
All right.